With IntelliSense getting crazy good and announcements around new extensions for Unity's integration with Visual Studio, I wanted to jump through some tips and tricks for novices, elites, and all those in between when using Visual Studio with Unity. By the end of this, hopefully you'll be navigating code like a ranger, writing code like a robot, and debugging code like an expert diffuser. So let's start at the beginning with installation. And I've added chapters to this video so you can skip ahead to get to the coding like a robot or debugging like your life depends on it. Now, we're going to need to install Unity's long-term support build, better known as LTS, and I'm going to put that in a website listed below. And if you're curious as to which build of Unity you should be using, well, I've got a video set up for that already that tells you which builds are which, and again, I'll link this in the description. As for Visual Studio, here is where we hit our first bump in the road. Which Visual Studio? We have both Visual Studio Code, Community, Professional, Enterprise. There are some paid for and there are some free. Now, I could go through all the features of each, but if you've watched my videos, you know that's just not me. So here is a quick flow to work out which one you need. If you're a small indie who doesn't want to pay and doesn't need all the bells and whistles, then Professional and Enterprise can take a long walk off a short pier. You just don't need them. Are you into Linux? Well, welcome to Visual Studio Code, as Community just won't work for you. Okay, so we know you're a small indie. We know you're working on Mac or Windows. You'll want to be writing C#. Well, they both do that. And you'll want to be debugging because you're not a crazy debug logger style person. Well, they both do that too. You only want to write the occasional basic class, well, then look at Visual Studio Code. And also, if you're limited on drive space, Visual Studio Code is still your friend. Now, if you want all the bells and whistles and you want things like code snippets, which I described below, then act like a Jedi and get yourself a Visual Studio Community. It's also the default option when you install Unity. Now, personally, I use Visual Studio Community, and I will show it in this video. However, you can debug using Visual Studio Code, so when I get to that section on debugging, I'll show you where that button is, like it is in Visual Studio Community. Links to all the Unity LTS download, Visual Studio programs, and all the other items I mentioned in this video will be in the description. Now we have our choices, it's time to get installing. First off, download and open the Unity Hub. Get the latest LTS version as mentioned, and we're off to the races. After it's downloaded, if you want to cheat on installing Visual Studio, just click the Add More Modules option and select Visual Studio Community. Now, during the installation of Visual Studio, I want to note that you kind of want to check the .NET and the Game Services for Unity selection. If you don't, you'll just have to do it later on. Now, once you're in Unity, you'd think that you're all good. However, you go to double click on a script and it doesn't open Visual Studio. Well, what gives? Well, you've got to set it in the Preferences option. So go to Edit, Preferences, External Tools, and make sure you have Visual Studio selected from the drop-down. This drop-down can also be used if you're loading up an old version of Visual Studio when you double-click and not the latest version you happen to have just installed. It's also worth checking that you have the Visual Studio package imported within your project. So open the Package Manager, make sure the drop-down is set to Unity Registry, and type Visual Studio in the search box. There are two options, Visual Studio Code Editor and Visual Studio Editor. Are you confused yet? Well, take it from me, you just need to have the Visual Studio Editor selected. There's actually an interesting blog post on the new release of the Visual Studio Editor shown here, and I will link it in the description. Now on to the good stuff and what you're really here for, the navigating, the coding, and the debugging. So we have Visual Studio installed. Now, how do we navigate around our codebase like a ranger expertly navigating a maze? Well, as I already mentioned, you can easily pop up a script by simply double-clicking on it in the Unity project view. However, we have other options once Visual Studio is opened. Let's start with project-wide navigation. Now, Visual Studio has a window called the Solution Explorer, which you can use to open up the various assemblies and find the file you're interested in. Now, if you're a good little developer, you would have already set up the assembly definitions in Unity to break up your code, reduce compile times, and enter the realm of making well-managed shared libraries across your projects. Now, that is a topic for another video. Let me know if you want it in the comments. But getting to my point, if you break up your code with these assembly definitions, in your Solution Explorer, they will be separated as well, making navigation a little bit more manageable. But wait, why limit yourself to the Solution Explorer when the Unity extension to Visual Studio also provides you with the Unity Project Explorer, which, as with the Solution Explorer, can be found under the View menu. Now, when we open the Unity Project Explorer, what do we find? But a mimic of our project structure in Unity, making it super simple to get right to the file we are interested in. While we're on a roll, if you know the name of the script, you can always just use the search at the top. It's another reason to make sure you have good class naming standards. But let's face it, trolling through the project views is probably not what we're looking to do. Most of the time we want to know where a method is called from, or where our class is used. When this is the case, we can right-click on the method or class name and choose Find All References. Boom! Every entry is shown to you, and hovering over those entries gives you a little sneak peek into their location. Now, if you believe opening up a file is so last year, you can always use peak definition. You can review and close the file for quick alterations and investigations. This one might come in especially handy for all those tabaholics out there who are trying to break their habit. So, you're in a class and you just want to find something. Well, just press Ctrl F. It will bring up a find box and you can jump to an occurrence as you type. You can then skip through the instances to find which one you need. Want to go outside the class? Add a Shift key, and you'll find instances further across your project. Let's roll with an advanced tip. I've shown jumping into another script that we own, but what about one of Unity's scripts? Well, let's take something like this XRGrab interactable script from the XR toolkit. This will open up as normal, as if it's one of the scripts you've actually created, and you can dive in and pick apart how it was made. This can really be helpful if you're trying to learn new tricks in different parts of the API. Oftentimes when I'm coding, I will find something completely new that I didn't even know existed that's written in one of these scripts. Funnily enough, when developers often ask me how I know about some of the lesser known features, this is one of the ways I find them. Now, in more recent years, the codebase from Unity has become a lot more informative. Take for instance this selectable script, which is what Unity's button derives from. Here we can see examples in the comments of how the elements of the script can be used. It's super handy for developers looking to extend Unity's classes rather than neighbour them with another component. Now, before we jump into the coding section, I would like to thank Unity for sponsoring this video. Now, this is a very niche little channel, so it's really great of them to come in and show their support to this developer community by sponsoring videos like this. So make sure to share this video to your developer friends if you think it will help them, and this will give Unity some incentive to support more videos just like this one. So, we know how to get around our code. Let's dive into creating some code, and how we do this efficiently like a master. Well, IntelliSense is our best friend here. As we type in code, it makes a good guess at what we want to enter and gives us options to autofill. Pressing the tab button will accept these options, just make sure what you're filling in is correct. Like most AI language models, it may interpret something a little differently. But at the same time, it might give you an option you didn't know, so don't just dismiss it at face value. One thing to note though is that selecting the option may add a new using statement to the top of your class, and if you decide to not use the code it provided you, you should probably go and delete that using statement as well. It's always good to keep your classes clean. Let's take a look at quick actions. This little puppy has saved me a ton of time and reduced many a copy and paste job. Now, you want your class to adhere to a particular interface contract, but when you add that interface, a little red line appears. Well, that's no problem. You simply right-click, select Quick Actions and Implement Interface. Boom, methods and properties are added and are ready for altering. Just make sure you then go through the interface elements and fill in the details, as you'll find a lot of not implemented exceptions lined up in your code. Why do these appear? Well, it's kind of self-explanatory. They're not implemented yet by you, so get to implementing. Using an abstract class, same option still applies. You just click on the class name this time. Too lazy to right-click and go through that menu? Then Control-Dot is your new favourite shortcut. Now, what about another shortcut tip? Well, let's say I entered a field and I'm about to enter another on this monobehavior. Just press Ctrl-D and a duplicate is engaged. This monobehavior needs to be set up for collision. Basically, we want to add some physics. Now, I know the method name, but I cannot remember its signature, the parameters, etc. Well, let's not bother going to the API docs. If I can remember the method name, all I need to do is start typing, and the Unity extension provides the method to autofill. But let's say I cannot remember the name. Well, if we press Ctrl-Shift-M, this brings up a window with all the methods of the monobehavior. So let's tick on collision enter and on collision exit. And suddenly those methods are ready for filling. And this doesn't just work for monobehaviors, it works for other classes from Unity as well. And as a bonus, if you're new to development, you can click on the generate method comments on this window, and it'll give you a little bit more context around what these methods actually do. Now, we're into our coding, and we're looking down the barrel of a method that's, well, it's basically getting a little bit bloated. Now in this case, we can make the selected code its own method. Now we could get to copying and pasting to do this, however, let's pop into our quick options again and slap the extract method option. Life just tastes better with good tooling. And as you can see, we can also do this for classes that have happened to crept into another class's file. We can banish it to its own file. Now, we don't always work in a bubble, and our memory is not infinite. So coming back to code in 2 years' time, after we've started, 2 or 3 unfinished projects and realized that the project we started with was the one we really wanted to continue. Now, this may lead us to questions on what some of our methods do because we didn't put any comments around them. Now, first and foremost, good naming often solves this problem without comments. However, typing 3 slashes above a method and suddenly, boom, a summary is approached. And we can fill this in with a nice, helpful comment entry. And it will appear for us, and now we don't need to have vagueness around our methods. It also helps when we're in another class, and we have a method loaded that we're not quite sure what it does. Well, we can hover over it and read our beautiful comment that we just wrote. And you don't need to be stingy. You can show the class some comment love as well. Now, this next tip is a little embarrassing. And it's something I know a lot of developers have problems with, but they hide away in the shadows, not revealing it to others. And I am one of those people. I cannot spell things for love nor money. And because I code quickly, the problem is just multiplied by thousands. Well, guess what? Visual Studio has a spell check function. That's right, no more typos. To turn it on, head to Edit, Advanced, Toggle Spell Checker, and then become hugely disappointed in yourself when lots of elements across your code start highlighting. Oh, your 5th grade teacher knew this day would come for you. Now, my next helpful tip with the Unity extension will really help you, and I mean that literally. Let's say you come across a Unity class, in this instance the monobehavior, and you want to learn a little bit more about it. Well, did you know you can jump straight to the Unity help documentation? No more copying and pasting into the browser and doing that search for you. You simply press the Ctrl-Shift F1 or, under the help, the Unity API reference option, and you're taken straight into the docs. And your browser supplier misses out on some much needed ad revenue. Now, let's get super advanced S-level tooltip. Even with IntelliSense, you find yourself typing the same thing over and over. We all do. Maybe you want to add all the collision elements quickly, without going to that method window. Or maybe whenever you add a serialized field, you're a good coder and you add a tooltip straight after it. Now you could just type them out every time, but that's not for us speed coders. We use code snippets. Now, if you go to the tools menu, you'll find code snippets under the code snippets manager. Now, this might get a little technical, so I've added a link to a walkthrough on how to add them and to get the details on the templates, etc. So you've got a template to start with. But in brief, we take a template and we add it to a folder on our drive. We then edit it to contain a code snippet, like the serialized field one we mentioned. And we want to add a few little details as you see here. Now we can add that file into Visual Studio and hey presto, when we start typing the word field, our code snippet arrives and saves us. But we want to go faster, we always do. Why are we then having to click back into the tooltip attribute to type our tip? We just don't have to. Back in our code snippet file, we can add a declaration and enter the ID for that declaration back into the snippet. Now when we type field, we enter and tab right back into the tooltip, ready to type. Now, if you didn't know about code snippets, I'm sure your mind is racing as to what things you duplicate all the time. Share your thoughts in the comments so others can have those and add them to their code snippets. Now it's time to code with some style. By now you've probably watched 5 other video tutorials on this subject. If you've done it before this one, don't worry, I'm not offended I wasn't your first choice. Now you might have noticed that your Visual Studio is colored differently than everyone else's. And let's face it, no real devs use the light theme, and all elite devs customize their themes. I'll let that burn a hole in the comments section where the flame wars will start. So how do we switch to the dark side? Well, you hit the Tools menu and jump to Options. The environment section is what you want, and in general you will find the color theme drop down. Now if you want more granularity, move on to Fonts and Colors section. Just remember, a pretty editor layout is less important than you getting your job done, but important to make your code more readable for you. In other words, fight back the urge to spend hours on it the first go around, just tweak it a bit over time. Now, I'm going to continue with the controversy. Something that's going to irritate many people out there, but I just don't care if I hurt people's feelings. So let's say code styles vary. For instance, some use underscores and some don't. Let's not judge too harshly. Now, I've worked in many AAA studios and many indie studios, and I know their styles vary. Anyway, you'll notice when you enter a type and then you go to name it, IntelliSense will try naming it for you. Now, if IntelliSense doesn't know your coding style, then don't blame it if you're constantly having to backtrack and enter an underscore. Now, if you want that underscore to appear for those names as you continue typing, pop into Text Editor, C# Code Style, Naming. Here you can manage naming styles and add a new entry. In this case, we add a naming style with an underscore. Then we could jump back into the new entry, drop down to what applies to us, in this case, private or internal fields, and then we select our required style. Now we can be best friends with IntelliSense again. Now, if you've been watching from the beginning, this is a lot of information to take in, and this video has expanded more than I first anticipated. I hope you're all still with me, because we're about to hit pay dirt with the debugging our code section. But before we do, as you can imagine, this video took me a lot of effort on my part, so maybe hit the like button, subscribe if you want more, and if you're sitting there thinking, wow, this is better than the education I got at school, and I paid for that, well, consider becoming a member or buying me a cup of tea from my Ko-Fi link. You'll find that in the description. Now, if you want to be a Unity ninja, you can also pick up one of my tools from the asset store or while supporting this channel. Again, links in the description. Now, sit down everyone. I want to talk about a problem amongst Unity developers, and that's adding a debug log everywhere to check that your code is working. Don't feel ashamed. You're probably in the majority of developers using Unity. Let's stop doing that, and instead we'll get some debugging going. So here we have our playable character, a space marine in a sci-fi environment using assets I grabbed from the asset store, and I'll leave links in the description if you want to pick them up for yourself. Looking at the setup, I have added an editor button for killing and inflicting damage to our space marine to illustrate a simple example of debugging in action. Obviously this example is simple to illustrate the process. So when our character is killed, they perform an overly dramatic death animation and they fall off screen. At the moment, pressing our kill button prints out a debug message but performs no animation. So that debug log isn't giving us any more information than the method is firing. Let's get to debugging. If I go into our character code and I find the kill method in Visual Studio, I can add a breakpoint by pressing to the left of the line here. Once I do that, a red circle will appear and the line is highlighted red. This means that when our code is executed, if this line is reached, the game will pause and Visual Studio will highlight the line ready for you to inspect it. Now, this won't happen until we attach Visual Studio to Unity. And to do that, we press the button at the top of the toolbar named Attach to Unity. That button will then change and we can get to our debugging. Now, for all my Visual Studio Code users out there, the Attach to Unity button can be found here. Back in Unity, we can run our game, and sure enough, when I hit that kill button, Visual Studio comes into focus and we can see our line highlighted. We can hover our cursor over the animator variable and we can get its current value. And sure enough, we can see here it's set to null. It seems like someone forgot to set it in the inspector. Now we can press continue and Unity will start playing again. But let's stop our game and we'll fix the animator assignment. Now if we press play and we press the kill button, we can see in our highlighted code that the animator is now set. We can now stop debugging because we've fixed the bug. And this will unattach Visual Studio in Unity and we can see our Space Marine taking its dive. Let's see another example. When our Marine takes damage, that kill method should be run as soon as the health reaches 0. Now we can see the health dropping on the inspector label above the button and also on the HUD overlay in the game. However, our Space Marine just refuses to die and we can clearly see the value is at 0. Let's jump into the code. Now I know my problem will be within the take damage method, so let's add a breakpoint on the first line. This time though, I will press my drop down and select Attach to Unity and Play. This will start the game automatically once Visual Studio attaches. No need to press the play button in the Unity editor. Now, pressing that damage button takes us to the breakpoint. Hovering over it, we can see the current health, and I can see what it's at the start of this function. I can now use the stepping functionality to step line by line in my code. Sure enough, step into the next line, I can see the current health has reduced by the incoming value. Next, we fire an action, telling the listeners that the health has changed. Next, we do our comparison, and we see that the health is over 0, and stepping again steps over the kill function, as we would expect. Well, all the functionality up to the condition, it seemed to work fine. So let's move our breakpoint to that condition. Now, when we press the damage button, it takes us to this new breakpoint, and we can see the health dropping by hovering over the current health variable. Now, to save us constantly having to hover over this variable, we can instead choose to watch it by entering the value in the watch window in Visual Studio. Now, we continue and again come back to the breakpoint. We can quickly see the current health, and we can see it's red, indicating its value has changed since the last time we saw it. Now we can press continue and repeat the process. However, we don't want to do this back and forth. So let's right click on our breakpoint and we'll select to add a condition. Here we can set the condition for when we want our breakpoint to activate. Let's say we're only interested when the current health is less than 5. Now we can continue and keep pressing our damage button until the health reaches our condition, without all the back and forth. Now let's take a look at our code. Yes, we've reached 0. But this condition is waiting for us to go below it, which won't happen with our current clamp statement above. We'll definitely need to fix that condition. But while we're here, let's take a look at a couple of other windows next to the watch window. We'll start with the intermediate window. With this one, we can do things like set variables to new values without having to use Unity to perform that action. Let's run the game again with our new condition code and with a new breakpoint that doesn't actually have a condition to it. When we hit this breakpoint, we're going to cheat, and we're going to enter into the immediate window that our current health equals 0. See how now the current health in our watch window became 0? And when we continue, we roll right onto the kill method without having to keep pressing back and forth. Now let's take a look at the call stack. This shows us the methods that got called to get to this point. We can actually double click on the line one down, and we are taken to the method that called our take damage method. In this case, it's the custom editor which has the button we pressed. This call stack can become incredibly valuable, say for instance if a method is getting called in your game when it shouldn't be. Let's see another example. When the game starts, the doors in front of our player open up. However, they then close before the player has even walked through them. What we have set up in our level is a zone the player enters that causes these doors to close. This seems to be running before our player reaches that point. Let's add a breakpoint in our onTriggerEnter event on that zone. If we run the game, that breakpoint then highlights just before the doors close. If we hover over the collider parameter, we can see that sure enough, the game object creature is causing this method to execute. Looking at our scene, we can see that creature has a layer of player instead of creature, which is causing this zone to actually execute when it shouldn't do. Now I should mention at this point that debugging is not just limited to the editor. You can debug a build of your game. When building, just choose development build and then put on the script debugging. And if you want your game to launch only when the debugger is attached, you can select to wait for manage debugger, which will pop up a little dialog box at the start of the game's launch. Once we've built our game and we run it up, we can see that little dialog appear and it's saying to attach. Now, take note of the number at the end. That's the port for this game. Now, in Visual Studio, press Debug, attach Unity Debugger, and select the option with the same port number that's on your dialog. You press OK on the game's dialog, and now the game runs with Visual Studio attached to it, and the same breakpoint is hit that we just looked at. With these tools, you can remove most of those debug log statements and debug like a professional. This really has become one of those long format videos I said I probably wouldn't do, but let me know in the comments if you found something useful. I might do some more of them. Also, share any more tips you might have. It always helps this channel's community, and they might also appear in a future video titled All the Things I Missed in the first video and you lot shouted at me about. And don't forget to like and share this video amongst your peers. As for me, it's time I got back to the fun party section of this game where the Marine meets the alien.